Okay, your starter should be coming up on the board in just a second. Actually, wants to work. Okay, let's have a look at these. Let's get a volunteer to give me an answer for one of them. Damon?
The second one?
Yep.
The fraction would be 3/4.
Good, the fraction would be 3/4, 3/4.
And the percentage would be 75%.
Excellent. It would be 75%. All right. Sorry there, folks. Okay, so going back to this. All right, Liza. Shh. Okay, so we've got the fraction 3/4. Thank you, Damon. And the percentage was 75%. Good. Give us another one, Eliza.
Okay, so the first one is for decimal 0.5.
Good, 0.5.
And then it's 50%.
And it is 50%. Good. Another one, Ian.
The third fraction is 3/10.
Good, 3/10. And the decimal?
0.30.
Good, 0.30 or just 0.3 is fine, okay? But both of those are correct. Any others? He hasn't answered. Delia?
I know one of these, I didn't really get right. But for the second last one,
Yep.
the decimal is 0.03, and then it's like continuing.
Why do I show that it's continuing?
The line of
The line or a little dot is fine as well. And what do we call that whenever it's continuing? We don't say continuing. Recurring, good. What about the fraction? Not 2/3. But 1/3. Right, good.
1/3 recurring.
1/3 is 0.3 recurring. And well, we've got two left. Grayson, give us one of them.
For the fourth one, the decimal is 0.03.
0.03.
And the percentage is 3%.
And the percentage is...
It's 0.0. No,
Oh, my bad. Mr. Cunningham's wrong. I was testing you, obviously.
Is this recording?
Yeah.
Hello.
0.03. And the percentage is 3%, correct. And the last one, Liam.
The one that I couldn't figure out.
Okay, what's the percentage?
Percentage is, I feel like 63%.
Not 63, just
Is 62?
62.5. Yeah, don't forget about the 0.5. And what about the fraction, Denham?
5.
Say again?
5 over 8.
5 over 8, how did you get that?
Because I know that 1/8 is 12.5.
Right.
So just added that.
Okay, good. 1/8 is 0.125, and then he added it up. Or you could, this is 625 over what? 1,000. And I can simplify this fraction all the way down to, how many times does 5 go into 625? 625 divided by 5 is 125. How many times does 5 go into 1,000? 200. And I can keep simplifying all the way down like that until you get to, sorry, Denham, what did you say again? 5 over 8. Cool. And we can check on the calculator. 5 divided by 8 is 0.625. Nice. Right, okay, so just to remind those of you that weren't here yesterday, I'm not going to be here tomorrow or Monday. So what you guys are going to do, you must have your laptop, okay? I think everyone pretty much has the e-assessment on there. I will put onto YouTube the link on the playlists. It'll be cover for M4, okay? This tells you This is a video on yesterday on how to use the e-assessment software, okay? How to get in there, the passwords, everything that you need, okay? I will also put on here in the cover for M4 what questions I want you to do. So you go on there and watch it, and there'll also be some trig stuff as well that I want you to complete. Does that make sense? Excellent. So going back to what we were working on the last couple of days, we were looking at graphs of sine and cos. And what is the amplitude of a trig function? Eamon?
The amplitude is half the distance of the full, distance, yeah.
Right, half the distance of the full distance. So I know what you mean. So you mean from the top, the maximum,
yeah,
all the way down to the
middle.
the minimum. Good. Okay, so it is half the distance from the max to the minimum. So looking at this, it's half the distance from the maximum down to the minimum. So the amplitude is 1, okay, because this graph goes as high as 1. What about the period? What is the period of a trig function of sine and cos? Yes, Liam? Yeah, when it starts to repeat. So we saw with these graphs that they start to repeat every how many degrees? 360 degrees. Okay, so that's where we finished up yesterday. I'm going to give you out this sheet. Okay, and we're going to complete this. Just to kind of start us off, I will give it out in a second, and we're going to draw these graphs of y equals 2 sine x to see what they look like. If theta is 0, what is sine of theta? 0, good. And what is 2 times sine of theta? 0, right, good, okay. What about, what is sine of 30 degrees?
0.5.
Is it 0.5? We can go back and check. Yeah, it is 0.5.
Oh, amazing.
Very good. So sine of 30 is 0.5. So what is 2 times sine of 30? 1. 2 times 0.5 is 1. So you have to fill out the table. You're going to draw it. Okay, I'm going to give you this, okay, to be able to draw it out so you don't have to draw your own axis. And then you're going to answer these questions about the amplitude and also about what the period is for each of them, okay? And you're going to look at 0.5 sine x as well. All good? I'm just going to put in another one of these just to show if you're not sure. If I want to work out the sine of 60, I can just do it in the calculator. I get my 0.866, then multiplied by 2, and I get 1.73. So this is 0.867, and then 1.73. Okay, and so on. Sine of 90 is 1. And when I multiply that by 2, I get 2, and so on, okay? Let's tidy this a little bit up. When you get all your values, okay, you're going to plot this one with this one first, okay, so theta with sine theta. That's just what we did before, okay, so you will get the same graph as, if I go back to, you will get this same graph here, okay? Yeah, okay, but you're only going as far as this point. Yeah, because that's all we've done in the table, okay? And then you plot the other ones. So then you're going to plot theta and 2 sine theta. You're going to plot this one and this one against each other and see how it compares. Yep. hopefully most of you have plotted your points on. If I go on to Desmos here, so you can see, let's put our, I want to look at between 0 and 360 was our domain. Okay, so the graph on the screen there, that is your y is equal to sine x. Okay, and most of you have put on y is equal to, how does it differ? Oh, sorry, 2 sine x.
Twice the amplitude.
Right, the amplitude is twice as big. Okay, we can see, what's the maximum point on 2 sine x? 2. What's the minimum point? So what is halfway between them? 2, right, so our amplitude is 2. Good. What about the period for 2 sine x? What is the period for 2 sine x? It's 360, because when does it start repeating? It starts repeating exactly the same time as just the regular sine x. So this is what you should end up with. Okay, you want to label them. So, yep. Okay.
Yeah, no, my, the answer is
All right, so the amplitude for sine of 2 sine x is all of that distance, which is a value of 2. All right, so the amplitude for this is 2. What do you think the amplitude is for 0.5 sine x? 0.5. How do you think that would look on here? Yeah, it's going to be half again. It would probably go up like that and back down and back up, okay? So, can somebody describe what this number in front of the sine x does? Yes, Crescent.
It decides the amplitude.
Yeah, it decides what the amplitude is going to be, okay? And it produces what kind of a effect to the actual graph? Like if you had to describe it in words, what does it do to the actual graph? Eliza? It determines the height, but what does it? It stretches it, right? Good, it stretches the graph. This number in front stretches the graph. So what about the amplitude for this one, for a sine x? Right, so whatever the number in front of sine x, a is always the amplitude, okay? Or the number in front of sine x is the amplitude. Good. And the period for each of these? Period for each of them is always 360 degrees. Okay, so we'll have a go at this part. Okay, we've only got about 6 minutes left. Okay, this is drawing 2 cos x. What you need to do is come up with a table again, and I'll give you some more paper to draw these, and we'll see what we get out, okay? So just to kind of show, if I put y is equal to 0.5 sin x, it's going to go up halfway.
Wait, that means it doesn't equal 0 once it gets to
That's okay. Just to kind of show what we're after for cost, okay? That's your graph for cos x. Starting at 1, you're going to draw the graph of y equals 2 cos x. And we predicted it's going to have an amplitude of 2, so it's going to start at 2, but be exactly the same shape, and have exactly the same period. Okay, so you're drawing those for me now.